After doing this module, you shall be able to learn about the various probability sampling approaches such as simple random sampling, systematic random sampling, stratified random sampling, cluster and multi-stage sampling. We shall also study the different non-probability sampling approaches, including convenience and purposive sampling. You would also learn when non-probability sampling approaches are applied. We would also see how to understand the way purposive sampling techniques of quota, model instance, expert heterogeneity, judgment and snowballing are applied in research. We would understand the way purposive sampling techniques of quota, model instance, expert, heterogeneity, judgment and snowballing techniques are applied in research. We would also examine the advantages and disadvantages of the various sampling methods. A sample is a group of units selected from the population used to draw valid conclusions about the larger group. Sampling is the process of selecting a subset of observations from an entire population of interest so that characteristics from the subset, which means the sample, can be used to draw conclusions or making inferences about the entire population. With the help of a diagram where you can see we have a population consisting of different persons in different rows, and we are taking a sample out of it and we have a small sample. So you, I'm sure, can make out from this diagram that what is population and what is a sample. Let us look at the probability sampling approaches. Probability sampling involves selection of samples based on probability and involves random selection. In this case, every unit in the population has a chance or probability of being selected in the sample. In fact, the probability of being selected can be determined. The different probability sampling or random sampling methods are: first, the simple random sampling; second, the systematic random sampling; the third is stratified random sampling; the fourth is cluster random sampling; and fifth is multi-stage sampling. Simple random sampling. Random sampling is a procedure by which each sample has an equal probability of being drawn out of the population, and within each sample, each unit has an equal chance of being selected or not being selected. It is the simplest of all probability sampling methods and useful when the population comprises of homogeneous units. We can have simple random sampling without replacement or with replacement. In sampling without replacement, an individual unit enters the sample only once. However, in sampling with replacement, a population unit can enter the sample more than once. Our objective under simple random sampling is to pick our sample in such a manner so as to ensure that all the units have an equal chance of being selected. The selection procedure adopted involves using a lottery system or table of random numbers or scientific calculators. For example, if we want to pick a sample of 5 students from a class of 50, we can write the roll numbers of all the 50 students on chits of paper and place them in a bowl or a hat. Subsequently, 5 slips can be drawn at random, and the students whose roll numbers are selected would form the sample. Alternatively, for larger or infinite populations, tables of random numbers such as Tippett's table, Fisher's and Yates table, or Kendall's and Smith's table can be used. In random number table, the digit 0 to 9 appear independent of each other and with equal frequency. So to select a sample, the population units are assigned numbers with equal number of digits. For instance, if the size of the population is less than 1000, then 3-digit numbers such as 000, 001, 002 to 999 are assigned. In using a table of random numbers, we may start at any place and may go on in any direction, either column-wise or row-wise. From this starting point begins reading the numbers. If your population size is 100 or less, read the numbers in 2-digit units. If it is 1000 or smaller, read the numbers in 3-digit units, and so on. If you come across a number in the table that is larger than the size of the population being considered, then skip that number and read the next. If a number repeats itself, you can skip that number and consider the next one. Continue with the process till you achieve the required or you find the required sample size. The sample obtained comprises of those units from the population having the same assigned numbers as those read from the table. Alternatively, random number can also be generated through softwares or scientific calculators, and the sample can be selected in the manner used with table of random numbers. In this method, there is no possibility of bias or subjectivity, as the sample units are selected at random, having each unit or giving each unit an equal probability or equal opportunity of being selected. For a homogeneous population, a random sample in general is representative of the population. However, simple random sampling requires complete information on the population and sampling frame. It is difficult to apply in case of a larger population. Further, picking up samples completely randomly can lead to inclusion of elements in the sample that result in practical difficulties such as geographic inaccessibility. Finally, a simple random sample could result in generation of samples, at least in case of heterogeneous populations that are not truly representative of the population. For instance, in a study of per capita incomes, using simple random sampling may result in selection of individuals with very high or very low incomes. Systematic random sampling, that the population is ordered. For a population of size n, if a sample of n units is to be picked, then a unit is picked at random from the first k units, and then every successive kth unit is picked as a part of the sample. The sampling interval k is equal to n upon n. Consider an example. Suppose we want to select a sample of 25 students from 150 students. The sampling interval k in this case is equal to capital N, which is the size of the population, divided by small n, which is the size of the students, and hence is equal to 150 by 25 and is equal to 6. Now select a random integer from 1 to 6. Suppose we pick 3. Then the sample selection begins with the third unit, and then every kth unit, in this case every sixth unit, is considered. Hence the sample would comprise of the third, the 9th, 15th, 21, 27, 30, 33, etc. And this will continue till the last unit. So we have a table which gives you an idea about systematic random sampling. Example. Systematic random sampling is an easy, low cost and convenient sampling method in case of large and infinite populations. It is efficient when the sample is to be drawn from a systematically ordered population, such as houses in blocks. However, the sample drawn is not completely random, not necessarily representative of the population, and also not free from biases. Further, in case the population size is not a multiple of sample size, then the actual sample size obtained is different from that required. The stratified random sampling. Stratified random sampling involves dividing a heterogeneous population into homogeneous groups or known as stratas. Subsequently, a simple random sample is considered from each stratum and these are combined to form the required sample from the population. Proportionate and non-proportionate. In proportionate sampling, subgroups representation is equal and proportionate to its relative representation in the population. For specifically in proportionate stratified sampling, for a population of size n, capital N, with k stratas of size ni, where I is from 1 to k, if S is the overall size of the sample, then the sample size of the ith strata Si is equal to capital Ni upon N, capital N, into S for all I. In non-proportionate sample, equal representation is given to all stratas regardless of their existence in the population. In other words, when the same sampling fraction S by N is used within strata, it is referred to as proportionate stratified random sampling. When different sampling fractions in the strata are used, it is referred to as disproportionate stratified random sampling. Let us consider an example. A sample of 20 students is to be drawn from 200 students consisting of 80 girls and 120 boys. If we use proportionate stratified random sampling, then the sample sizes SB and SG for boys and girls respectively should be SB should be equal to NB upon N into capital S, which means it should be equal to 120 upon 200 into 20 and comes out to be 12. Similarly, SG, which is the size of the girls in the sample, should be equal to NG upon N into capital S, and therefore this is equal to 80 upon 200 into 20, it is equal to 8. It therefore means that we should have in our sample of 20, 12 boys and 8 girls. This is also shown with the help of this diagram or figure 2 of stratified sampling. So stratified sampling gives more representative samples and ensures greater efficiency. However, it is more time consuming, costly, and requires greater statistical expertise given the fact that the population has to be divided into homogeneous strata. Improper division of the population could give rise to biased samples. Cluster sampling. Cluster sampling is indicated when the population consists of clusters. A cluster has the property that within a cluster, the variance is large amongst members of the cluster, but between clusters, the difference is small. We can see that in the figure, and we have different population clusters A, B, C, D, E, from which we have the sample values given in cluster A and B. So suppose NDPL, which is a New Delhi Power Limited, wants to conduct a survey of households that consume electricity. If each cluster in each locality is a DDA colony, then it could be expected that it would consist of HIG, MIG, LIG and Janta or EVS flats. Therefore, some of the areas of Delhi like Janakpuri, Narayana, Kalkaji, Dilshad Garden or Ashok Vihar would be similar to each other. But within each colony, there would be a collection of clusters or a variety of people. Therefore, NDPL has to survey only 2 of 5 colonies for obtaining a 20% sample. Thus, cluster sampling is useful when a large geographical area needs to be covered. It helps cut costs in this case. Reliability is higher because there is no arbitrariness in selection. Hence, there is no selection bias. Multi-stage sampling of cluster sampling. In this method, the process of cluster sampling is applied repeatedly. In the first stage, sample clusters are picked, and in the second stage, instead of considering all the units of the cluster, a sample of units is randomly selected. If required, further sampling is undertaken in the selected clusters. Clusters in the first stage are called primary units, and in the second stage are called secondary units, and so on. It is a complex type of cluster sampling. Here, two or more levels of sampling are nested in one another. For example, for doing a sample household survey in Uttar Pradesh, UP, the Statistics Ministry has to choose a 20% sample. The three levels are districts, talukas, and villages. In the first stage, two districts are randomly chosen in the state. Let me repeat, in the first stage, two districts are randomly chosen in the state. Then two talukas and subsequently two villages are selected. The three levels are districts, talukas, and villages. In the first stage, two districts are randomly chosen in the state. Then two talukas and subsequently two villages are selected. Finally, sample households are chosen from the selected villages. All ultimate units selected at last step are surveyed. A few advantages of this method are: it is an effective strategy because it rests on multiple randomization. Multi-stage sampling is frequently employed when a complete list of all members of the population does not exist. Moreover, by avoiding the use of all sample units in all selected clusters, multi-stage sampling avoids the large and perhaps unnecessary costs associated with traditional cluster sampling. The method has, however, also few disadvantages. These are: a primary disadvantage is that there is some deliberate structuring of the sampling frame. Therefore, it is not a purely random sample. This technique is essentially the process of taking random samples of preceding random samples stage by stage. Another disadvantage is it is not as effective as true random sampling, but probably solves many of the problems inherent to random sampling. For instance, the same units may be one-sided in pure random sampling. In India, stratified multi-stage sampling is used by National Sample Survey Organization or NSSO for its employment, unemployment, and other surveys. Multi-stage sampling involves lower costs and greater administrative convenience. However, each sample may not be a full representative of the whole population, and thus this method could lead to lower efficiency. Non-probability sampling approaches. In non-probability sampling, the sample selection is not random. Hence, the samples are not derived on the basis of probability. In general, it is difficult to assess if non-probability samples truly represent the population, as the probability of representing the population is not known. However, in certain cases, random sampling may not be applicable and non-probability substitutes needs to be considered. Non-probability sampling is applied when randomly picking up samples in cases such as infinite populations is not possible. We also use this when generalization of results from the sample to the population is not a requirement of the study. Also, when time and cost constants are present. And finally, when the study involves a qualitative or a pilot survey. Non-probability sampling methods can be divided again into convenience or accidental and purposive sampling approaches. Convenience sampling is the most common form of sampling used in social science research and simply involves the selection of units that are available for study. In purposive sampling, the sample is selected with an unambiguous purpose, and thus the choice of sampling units depends entirely on the discretion of the investigator. Purposive sampling techniques broadly takes the form of quota, model instance, experts, heterogeneity, judgment, and snowball sampling. Convenience sampling. It is also known as accidental or opportunity sampling. It simply involves the use of that part of the population as a sample that can be easily accessed by the researcher. In this case, generalizations about the population from the sample may not necessarily hold, as the sample would not be representative enough. In convenience sampling, no prior inclusion criteria is identified for selection of subjects. This sampling method is useful for conducting pilot studies. It entails lower costs and time. However, convenience sampling is highly vulnerable to selection bias and sampling errors. Further, the results obtained cannot be generalized to hold true for the entire population. This is clear from convenience sampling, where we have the population and we have just picked up the convenience sample, maybe in this example of the first 4 subjects. For example, to evaluate the 4-year undergraduate program, if only volunteers are interviewed, it would constitute a convenience sample. Another example would be if a coffee chain joint wants to access the favored coffee flavor among college students. In this case, they could simply visit a local college and randomly pick a sample. However, their research would not be accurate for the entire population of all college students. Purposive sampling. Purposive sampling involves conscious selection by the researcher of certain people to be included in the study based upon criteria such as experts' knowledge of a particular issue or certain experiences or willingness to participate in the research, etc. Thus, sample units are selected based on particular characteristics that are of interest to the researcher. Purposive sampling does not randomly select units from a population to make statistical inferences from that sample. Rather, it focuses on particular characteristics of a population that are of interest to the researcher. Purposive sampling represents a group of different non-probability sampling techniques. The choice of the sample, in fact, depends on the type of purposive sampling technique that is used. Some of the purposive sampling techniques we discuss include quota, model instance, expert, heterogeneity, judgment, and snowball sampling. Let's understand quota sampling. This sampling involves selecting samples based on fixed quotas, which in turn are based on population proportions. The quotas are based on specific characteristics of the population such as age, gender, education, community, locality, religion, etc. For example, if we are interested in analyzing the optional subject preferences of college students, we require a sample giving adequate representation of both the genders. Thus, for a sample size of 100, the number of males and females considered in the sample would depend on the overall male-female ratio of students in the college. The second example could be model instance sampling, considers the most frequently occurring or typical cases. The samples considered do not comprise of extreme cases. The typical case sampling is not used to infer generalizations about the population, but rather these samples are used to study average or normal behavior. The third example is the expert sampling. It is used when the research requires knowledge from individuals having particular expertise or skills. It is essential to recognize the expert sampling units. Thus, as a prerequisite, it is essential to lay out the criteria used for categorizing someone as an expert by means of experience or qualifications, and consider only those units fulfilling the identified criteria as a part of the study. Inadequate empirical support, uncertainty, and controversies call for expert sampling. Let us now try to analyze the meaning of heterogeneity sampling. This type of sampling involves the study of wide range of perspectives relating to the research undertaken. This is done so as to incorporate different perspectives. The sampling units comprise of a wide range of participants who are picked so as to be able to acquire a broad knowledge of ideas regarding the research undertaken. These units exhibit maximum variation with respect to attributes, qualities, experiences, etc., so as to enable an understanding of the research phenomena from diverse viewpoints and to help identifying common factors. Let us now understand judgment sampling. Judgment sampling involves picking from the population the sample considered to be the most appropriate based on the judgment of the researcher. This sampling method is prone to researcher bias as the samples are selected according to his judgment. Since the sample subjects are not randomly picked, hence the results cannot be generalized. It is useful when a small number of individuals possess the characteristics that the researcher wants to study. Further, it involves lower time and costs. A typical example would be if a researcher is interested in finding out what it takes to score the highest percentile in common entrance test known as CAT. In this case, the only participants in the sample would be people who have secured the highest percentile in CAT. Snowball sampling, which is another form of sampling. This sampling involves recommendations or referrals from existing sample units for identifying potential sample units. The process continues till the sampling requirement is met. So, small population sizes warrant the use of this approach. Involving drug or alcohol addicts or HIV or AIDS, this approach is generally followed as it is otherwise difficult to identify potential sampling units. Having identified a few sampling units, their recommendations or support group information can help ascertain other potential samples. Snowball sampling can be linear, exponential, non-discriminative, or exponential discriminative sampling. Though the samples arrived at are not truly representative of the population, however, this method is practical when target populations are difficult to identify and approach. I am sure this is clear from this diagram where we have the investigator and the researcher, and we have in a way the trees or the branches of the trees showing us the subsets of the different targeted population. The process of selecting a subset of observations from an entire population of interest so as to draw conclusions about the entire population. We have learned that there are basically two approaches to sampling: probability or random sampling and non-probability or non-random sampling. In probability sampling, it involves selection of samples based on probability and involves random selection. Different probability sampling methods which we have studied include simple random sampling, systematic random sampling, stratified random sampling, cluster sampling, and multistage sampling. We have learned in random sampling that it is a procedure by which each sample has an equal probability of being drawn out of the population, and within each sample, each unit has an equal chance or equal probability of being selected. Systematic random sampling is an easy, low cost and convenient sampling method in case of large and infinite populations. Stratified random sampling involves dividing a heterogeneous population into homogeneous groups or stratas. Subsequently, a simple random sample is considered from each stratum, and these are combined to form the required sample from the population. We have learned that in cluster sampling, it is basically indicated when the population consists of clusters. A cluster has a property that within a cluster, the variance is large among members of the cluster, but between clusters, the difference is small. Multistage sampling, on the other hand, is a complex form of cluster sampling. In this method, the process of cluster sampling is applied repeatedly. On the other hand, the non-probability sampling is applied when samples cannot be randomly picked or when generalization of results is not a requirement of the study. It is also advisable when time and constraints are present, or if the study undertaken is a pilot survey or qualitative study. Non-probability sampling methods can be divided into convenience sampling or purposive sampling approaches.